Okay, hi folks. Today we are looking at conics and writing and graphing ellipses. So remember, the ellipse is one of the conics sections, and so the objectives are listed there. We'll let you read those. Graph ellipses with center at the origin, write equations of ellipses in standard form, and then graph ellipses with the center not at the origin, and then solve applied problems involving the ellipse. I think I'm going to save those types of problems for the class after we get all of the conics sections done. So it's kind of just a rigmarole of getting the equations and understanding how to graph these. So the diagram that you see to the left of the box, after the essential knowledge, know the definitions of the foci major and minor axis, vertices, co-vertices, eccentricity of an ellipse, derive the equations of ellipse in standard and general forms using different givens, calculate numerical properties of an ellipse given its equation. Now, so back to what I was saying, the ellipse that you see here, the definition of an ellipse is really the set of points that have a constant sum of the distances from the foci to the point. So you have two distances there. So you see D1 and D2 and D3 and D4, the red and the purple respectively. D1 plus D2 will always be equal to D3 plus D4. So if I put another point on here, over here, and I set up a distance here and here, the sum of those two pieces will also be equal to D1 plus D2. Okay, so the graph of each of the following equations for an ellipse with center at the origin having the given properties, given the equation, it's of the form x squared over a squared plus y squared over b squared is equal to 1, with a greater than b in this case. So the major axis in this case is going to be a horizontal axis, and the length is going to be 2a. So you can see the diagram down below. The major axis is the longer axis. Okay, and the vertices are on the endpoints, negative plus or minus a0. The vertical length is going to be 2b, so your b comes into play there for the minor axis that has a length of 2b. And then we get the foci by c squared is equal to a squared minus b squared. And then for when we have a vertical major axis, you have x squared over b squared plus y squared over a squared. A squared is always the component of the major axis. So you can see that the vertical length is 2a, and now the horizontal length would be 2b. And then the foci would then be on the vertical axis. You can see the foci here and here on the horizontal axis, and here's the foci here and here. So let's take a look at this first example that I have for you. Okay, I'll let you study that a little more. If you want to pause the video and take a look at those definitions. So we are right here. Now, an ellipse has the equation x squared over a squared plus y squared over b squared is equal to 1, right? So in this case, I chose that one because if you're looking at this, 9 is greater than 4. So I'm going to do a little highlighting here. So 9 is greater than 4. So that's the form where a squared is with the x. So that means that the major axis is horizontal from the information above. Okay, so this is my equation. So then I have a squared is then equal to 9. Therefore, a is equal to 3. And we're just going to make it a positive 3 for our benefit. It's really plus or minus 3, but it's okay if we just leave it at 3. B squared is 4. So then we know that b is equal to 2. Then c squared is equal to a squared minus b squared. So c squared is 9 minus 4. So we get c squared is equal to 5. And then we know c is equal to the square root of 5, which is approximately 2.24. Okay, so in order to set this up, what we're going to do is we're going to plot from the origin, the center in this, assign the foci, the vertices, and the lengths of the major and minor axis, and sketch the graph. So in this case, I've got the vertices in here at -3 and 3. So we go over a units to the right and a units to the left, 3 units. And then I go 2 units up. This is my b distance, and 2 units down. And what I'm going to do is then connect those into a nice oval. Let's see if it sticks. Oh, there it goes. Pretty good. Okay, so I have a pretty good oval there. And so I can see that the foci I don't have, but I know that the vertices are plus or minus 3, 0, right? The foci in that case then are going to be plus or minus, I'm going to put them in, I'll put them in red. So red right here, 2.24 here, and 2.24 here. The x-axis, remember, is the major axis. So here's the first one, here's the second one. So 1 and 2. Okay, so those are going to be plus or minus root 5, 0. Okay, now the length of the major axis is going to be 3 plus 3, or 6. Hope you can see that. From vertice to vertice. The length of the minor axis from -2 to 2 is then going to be 4 along the y-axis. So now the second part of this is so we have all of our information. We have the foci, the vertices, and the lengths of the major and minor axis, and then we sketch the graph. Okay, now with a graphing calculator, if you want to graph this, you're going to have to solve for y. So I did the first step there where I brought over the x squared over 9, and then I multiplied by 4, and then I'm going to get y is equal to plus or minus, that square root of 4 is going to be 2, and then times the square root of 1 minus x squared over 9 then. Okay, so I have the plus or minus. So what I would do is I'd put in y1, I'd put in that plus 2 times the square root, and then for y2, I'd put in negative 2 times the square root, 2 times the square root. And then whatever you see here in the root, 1 minus x squared over 9, you're going to put that in. Okay, so you'd have to put in 2 equations to get this graph. The plus is going to be the top part of the ellipse, and the minus 2 is going to be the bottom part of the ellipse. Okay, let's move on to the next one. Hope that was good. So the second one, we want to find the foci of the ellipse. 16x squared plus 9y squared is equal to 144. So the first thing that we're going to do is we're going to divide both sides of the equation by 144. Because remember, we want this form. We want to get that form where the right-hand side is going to be 1. So once we do that, if we divide both sides by 144, we're going to get x squared over 9 plus y squared over 16 is equal to 1. That tells me right away that my major axis is a vertical axis because the bigger the denominator, the y squared, is bigger. So 16 is greater than, if you look at it this way, 16 is greater than 9 in this case. So it's going to be, think of it like this. The y squared will tell you, oh, it's vertical, like the y-axis, because the 16 is bigger. Like the other one where in the previous example with the x squared, 9 was bigger than 4. So the major axis was then going to be horizontal like the x-axis, okay? It was the x-axis. All right, so now that we have our equation, okay, in step 2, so we want to sketch this graph, right? So we have a is square root of 16, so a is equal to 4. And then we also know that b, where do I have b? B squared is then 9, so we know that b is equal to 3. So we can graph the endpoints and get our oval here. So we're going to go up 4, down 4 on the vertical axis. Remember, the center is 0 for this one. So let me see if I can draw it in one fell swoop, and we have an oval that looks something like that. Not too bad. Okay, try to put it on the vertices as best you can. Okay, and there you go. There you have it. Okay, so I've got my ellipse graphed. Now we want to get the c. So remember, c squared is then equal to 16 minus 9. A squared is 16, and b squared is 9. So we get c squared is equal to 7. So then we would have our c value is approximately, well, it's exactly square root of 7. So many of you may know this already, that that's approximately about 2.5, but it's 2.6457513, somewhere around that. Okay, you can check me with a calculator. I think that's about the value. So when we graph these, the thing is, in blue, you can see that I already have the 2 points here, foci 1 and foci 2. And it's a pretty narrow shape. C is, I have that 2.64. I guess it's in the right place there. Okay, 2.64, so what else do we need? I think that's about it. The other thing you can do is you can go back and try to solve for y And again, that's what you're going to get. And then you can graph the positive in y1, the negative square root in, or the expression in y2, and see if you have the same graph. So there is a vertical example. For example 3, we want to find the equation of an ellipse. So the vertices, we're given the vertices of an ellipse are plus or minus 4, and the foci are plus or minus 2. Find its equation and sketch the graph. So we have the equation in x squared over a squared plus y squared over b squared equal 1 form. Now, when I look at this, I'm saying the vertices are and the foci are. So since they give you the foci with the vertices, you know that the major axis is the x-axis in this case. So you have from negative 4, 0 to 4, 0 on there. So the first thing I want to do is then find the foci. So that's going to be 2 squared, c is 2, as I have up here, and a is 4. So I have 2 squared is equal to 4 squared minus b squared, because I need the minor axis b value. So I get 4 is equal to 16 minus b squared. So then I have b squared is equal to, b squared is equal to 16 minus 4, or b squared is equal to 12. B is then equal to 2 root 3. Okay, now remember, we're just using the positive value for b, but it's, again, if you're going to graph the foci, you want to know approximately what that is. So remember, square root of 3 is 1.73, so 2 times that is going to be 3.46, about 3.46. Okay, 3.46 to get the value. So we have the information for the equation. That's what we want to do. Find the equation, sketch its graph. So our equation form would then be x squared over 16 plus y squared over, remember, x squared. X is the major axis, it's the bigger number. So it kind of makes sense that we get b squared. We're just going to put the 12 in there, is equal to 1. And then we just want to sketch the graph. Okay, so it's almost round, right? If we do this, I bet it turns out to pop into a circle because it's so big. That's what it wants to do. Okay, so I'm going to draw each part and see if I can be pretty accurate with that. Yeah, the circle draw on the Notability just wants to make it a circle because it's pretty round. It's kind of like our planetary orbits. When you consider our planetary orbits are almost round. I'm going to redraw this part. Not liking that. Okay, and yes. Okay, as we'll talk about, that's our graph. We've got everything we need there. And remember that we're looking at when we are given the vertices and the foci, that tells you both of those occur on the major axis, so we know it's horizontal in the x-axis when we started that problem out. So not too bad. Okay, we go on to example 4. We've got an interesting table. I'd like you to pause the video and kind of take a look at the orbits of the planets here. And here's Earth right here. You can see that the eccentricity is the topic. We're talking about the flatness of the circle. When the E value, the focus over the A value, remember A is the vertice. If the focus is pretty close to the vertice, then your E value, let me say that differently. If the focus is really close to the vertice, you're going to have a C over A. If it's going to be close to 1, then you're going to have a pretty flat ellipse. But if the C value turns out to be pretty close, think of the center, C. If the focus, the C value, is pretty close to the actual center, then your orbit, if you will, is going to be fairly circular. So that means E, the eccentricity, will be very close to 0. So think of it like this. You're going from 0 to 1. If E goes to 0, you're going to be pretty circular. If it goes to 1, it's going to be a really squash. The closer it gets to 1, it's going to be a very narrow ellipse, okay? So you can see that all the planets have a nearly circular orbit by the value 0.0717. Sorry, 0.017 is the eccentricity of the Earth. So that's why Galileo, a lot of the, when they finally discovered, the Earth goes around the sun, and we picture it as circular orbits. They're nearly circular, but not actually circular. As we'll talk about the distance that the Earth gets. There's a part there, and I have a little picture of it here. The perihelion is when the Earth is closest to the sun, and then you have the aphelion where the Earth is furthest away, and that's the orbit of the Earth, you see, as it goes around the sun. And the sun is actually at a focal point, so kind of cool, right? All right, so with this problem, you want to find the equation of the ellipse with the foci 0 plus or minus 8 and the eccentricity E is equal to 4/5, and then sketch its graph. So we have to start off with the value that we have for E, and we have the foci. So we actually know what C is, right? So we know that E is equal to 4/5 here on the first, and then E is C over A that you're getting from the formula to give you your eccentricity, the flatness. So we get C is equal to 8, right? C is equal to 8. And how do we know that? Because the foci are 0 plus or minus 8. You can see that I have those already in there in pink on the y-axis. So then C is equal to 8. So all I have to do is set the eccentricity equal to 8 over A with this formula, C over A, and then solve for A. So you can kind of see with that I get C over A is 8 over A now. So I get cross multiply, and you get 4A is equal to 40. So we get A is equal to 10. A is equal to 10. And now remember what you're going to do. You want to find the equation of the ellipse here. So you need A and B. You need A squared and B squared for that. So we start off like this. We know C squared is equal to 8, 8 squared. And now we know that A is 10. So we have 10 squared here. So, oops, I don't need equal. We want a minus, and we want to find B squared. So I can flip the B squared. B squared is then equal to 100 minus 64. So that's equal to 36. So we know B squared is equal to 36, and then B is equal to just plain old 6. The major axis in this case is going to be A is equal to 10, is going to be on the vertical axis. You already know that because the foci have to be on the major axis. So we've got the 10 and the negative 10 here. You can see I'm just darkening them in there. And then we put the B in, so we're going to go 6 units either way, where I went 10 units up here. This is our A value, and B units over to the 6, and then the other way as well. And we'll draw our ellipse. There's our ellipse. And then, so we know the equation is x squared. Let me get a black here. So we have x squared over 36. Almost put 100 there. 36 plus y squared over 100 is equal to 1. Okay, so there is our equation, and I think that is all that we need to find right now. You can see I stuck the foci in there. We know that C is equal to 8. That's already in there. 8. Anything else? And there's our little Earths. And one more problem to do. So sketching the graph of a shifted ellipse. So what you're going to do in the same way that we worked with parabolas, we are going to shift. So we're going to subtract, we get the center of the ellipse, HK instead of 0. So this is the form for the ellipse when you shift it. And there's a chart in your Schoology. So what we're going to do is the same thing we did before, is we're going to start out, we're going to look at the form, we're going to say, all right, well, I know the center, I have it written down here, is going to be -1, 2, because that's coming from your form HK. This is your HK here. So we have the HK, -1, 2. And then we look at our denominators, and that's right here in red on the graph. And then we have A is equal to 3 and B is equal to 2, given that we have A squared. Now, this is going to be a vertical axis. Notice that it's the vertical major axis because the bigger number, 9 is bigger than 4. So that's with the y minus 2 quantity squared, major axis. So then the next step is you want to get your C. So you have C squared then is equal to 9 minus 4. C squared is equal to 5. So C is then going to equal to the square root of 5. Okay. Now you can see that I've got my center is -1, 2. And I left the 1, 2 on the ground there. I meant to erase that, but I'll leave it. So I start from the center, -1, 2. And I know that I'm going to be adding 2 and going to the right 2, to the left 2 on the minor axis. And then I'm going to go up 3 and down 3 on the major axis, okay? So I've got those points. I'm just going to put the coordinates with it. I'm going to graph the ellipse. The scale is a little bit wonky, I think, but I think it'll do. And it wants to be a circle again. So maybe if I go like this, and it's a skinny ellipse, I'm going to make it fatter, make it a little bit there. It's almost right there. Okay, so there's my ellipse. Good enough. All right, so now to get the coordinates, I'm just going to start with the vertices along the major axis. And remember, the x value is going to stay the same, -1. I'm just going to change the y value. So what I'm going to do then, let's go purple. I'm going to take the y value at the center, 2, and I'm just going to add 3. And I'm going to take the y value at the center and subtract 3. Because I'm going to go up 3 and down 3. So that's going to give me -1, 5. So that's up here. -1, 5 is up top. And then -1, and it's going to be -1 down here. -1, -1 down here. And then for the co-vertices, remember, the y value is going to stay the same. And then you're going to start at -1, and then you're going to go over 2 units. 2 units, so you're going to add 2, and you're going to start at -1, and you're going to subtract 2. So you would have then the points 1, 2, which you see on the graph, and then you're going to have -3, 2, and we'll put that over here, -3, 2. So those are the co-vertices. Then to get the foci, you're going to start, and they're on the major axis, so we'll put those in then. So I'm on an x value of -1, so I've got to start with the 2, and remember I have to add square root of 5, and then I'm going to start with the 2 and subtract square root of 5. So, I mean, our points are really approximately, if you see 2 plus 2.24 is 4.24. So if I graph that, 4.24, 1, 2, 3, 4, 4.24 is going to be pretty close right up here, right? So there's the focus, there's one focus. And then if I say -1 and then 2 minus a square root of 5 is 2 minus 2.24. So it's going to be -2 minus 2.24, -0.24. And so it's about right there. Okay, so you can see your focus, your second focus is here. And I hope this video is not too long. I want to talk about so much more. There's so many cool things, such as if you look at the Whispering Wall and the Statuary Hall in Washington, D.C., and the Whispering Wall in Grand Central Station. Those are 2 examples of some of the applications of ellipses. So we'll talk more about that tomorrow in class. I hope you have a great night, and I'm sorry I got this out a little bit later than I wanted to, but I'll be using this year after year anyhow. So have a good day. Talk to you soon. Bye.